Hello, ladies and gentlemen, this is Mrs. Gallagher. And today's learning goal is we're going to write function rules using real-world problems and applications. So just as you can translate words to an equation, you can also translate words to a function rule. So we're going to translate our words into a function rule. We want to be sure to identify the input and output of the word problem. So we want to identify our input and output of the word problem. Now there's 3 steps when we are creating function rules using word problems. Step 1, you want to identify the initial value and rate of change. Remember, the rate of change is also our slope. So our first step, we want to identify the initial value and rate of change. The rate of change is the slope. So the initial value, what is our initial value? Your initial value is the y-intercept of the function. It represents the initial cost or the starting cost. So your initial value is your y-intercept of a function. It represents the initial, also known as the starting cost. Your rate of change or slope represents the change. It's the input. It's where the variable belongs. It's where the variable goes. The variable always goes next to the rate of change or the slope. So the rate of change or the slope represents the change, which is the input value, and it's where the variable goes next to. Our second step is you want to define the input and the output. So step 2, you want to define the input and the output. Step 3, we're going to write the function rule in slope-intercept form, y equals mx plus b. So step 3, we're going to write the function rule in slope-intercept form, y equals mx plus b. Now let's recall what our input and output values are in our slope-intercept form, y equals mx plus b. Our y value is our output. That is our range. So our y value is our output. Our x value is our input. That's our domain. So our x value is our input. That's our domain. So now after we learn these steps, let's answer some problems together. Okay, let's look at example 1. It says the price P of a pizza is $6.95 plus 95 cents for each topping T on the pizza. So we want to basically create a function for this. But in this example, we want to first identify what is the initial value and rate of change of the function. So our initial value, what is the cost of pizza no matter what? The cost of pizza is $6.95. So no matter what, our cost of pizza, our initial value is $6.95. That is our initial value. That's also our y-intercept of the function. Our rate of change. So what's changing in this problem? Well, the amount of toppings. So 95 cents for each topping is our rate of change. So 95 cents for each topping is our rate of change. However many toppings there are is how much more or less our pizza is going to cost. Our next step is to define. And what we want to do is define our input value and our output value. So what's our input? What is going to change the output? Well, each topping. So our input is the number of toppings, which is T. So our input is the number of toppings, it's T. However many of toppings we have is going to change the price of our pizza. Therefore, our output is the price of pizza, the P value. So our output is the price of pizza. And now what we want to do is we want to write our equation. And the equation is also known as your function rule. So we want to use slope-intercept form to write our equation. Y equals mx plus b. So if you recall, y is our output. So what's our output in this problem? Our output is equal to our price of pizza. That is our y. Therefore, we're going to put P as our output. Equals, your M is your rate of change. This is your M, your rate of change. And we identified our rate of change as 95 cents a topping. So put 0.95. Our X is our input value, which is the number of toppings, which we said is T. Plus, our B is equal to our initial value. So our B is our initial value. So plus 6.95. Therefore, our answer is P equals 0.95 T plus 6.95. So our function rule is the price equals 95 cents a topping plus the initial cost of pizza, which is $6.95. Let's do another example together. Example 2. A worker's earnings, E, are a function of hours, H, worked at the rate of $8.75 per hour. So let's identify our initial value. Well, if we look here, it doesn't say anything about an initial value. All it tells us here is we have $8.75 per hour. So our initial value here is none. There is not an initial value. We're not starting at anything. There's no starting rate. Therefore, there is no initial value. Our rate of change in this problem, well, what changes? The number of hours, $8.75 per hour. So that's our rate of change. That's our slope. Okay, so our rate of change, your slope, that's your M. And refresh, your initial value is your B. Next, you want to define what's our input, what's our output. Well, our input in this problem is the number of hours he works. Your H. So your input is the number of hours the worker works. That's your H. However many hours is going to change his output, which is the worker's earnings, your E. So your output is your worker's earnings. That's your E value. So now we want to write this and put this all together. We're going to use our slope-intercept form, y equals mx plus b. So now let's identify our output, our rate of change, our input, and our initial value. So your output in this problem, we identified as your worker's earnings. That's your E. So E equals, my M is my rate of change, which we identified as $8.75. Your input, your X value, is your number of hours he works, the worker works. So that's your H, plus our B here, well, there wasn't a B, there's none. Therefore, your B is equal to 0. And do we need that 0 there? No, we don't. So let's simplify this. Our earnings equals $8.75 an hour times H. So your function rule is E equals 8.75 H. Let's do one more example together. Example 3. A kennel charges $15 per day to board dogs. Upon arrival, each dog must have a flea bath that costs $12. Write a function rule for the total cost for n days of boarding plus a bath. How much does a 10-day stay cost? So another question's added here. They want to also know how much a 10-day stay is on top of writing a function rule. So let's look here. We know it charges $15 per day. And we know each dog must have a flea bath, which costs $12. So our initial value, no matter what, each dog needs a flea bath. So our initial value is $12. So no matter how many days the dog stays there, they have to add a flea bath, which costs $12. Remember, your initial value is your B. Okay, so our rate of change, or our slope, which is our M value. Our rate of change is the amount of days. So it's $15 per day is our rate of change, our slope. All right, so we identified our M and our B. Next, we want to identify our input and our output. So our input, what's going to affect our total cost? Well, the number of days. Therefore, your input is the number of days. And the number of days is identified as N days. So your input is the number of days. Your output is your total cost. That's your range. What is your total cost after the number of days and the flea bath? So your output is your cost. Now I labeled cost as C. So our next step after we identify our input and output is we want to write a function rule. And again, we want to use our slope-intercept form, y equals mx plus b. So your y is your output. So we have C equals, because we identified our output as C. Our m is the rate of change, which is $15 per day. So 15. Our x, our input value, we identified as n, which is the number of days, plus our b is our initial value, which we identified as $12 for the flea bath. Therefore, our function rule is C equals 15n plus 12. Okay, so now we just found the function rule, which is C equals 15n plus 12. And our last question is asking us, how much does a 10-day stay cost? So our 10-day, what does that stand for, 10? Well, we identified our input is the number of days. Therefore, our 10 is our n value, our number of days. And if you read the question, it's asking you how much does a 10-day stay cost? So we want to find our cost, our output. Therefore, we're going to rewrite our function rule as C equals 15n plus 12. We're looking for a cost. So 15 times the number of days is 10 plus 12. C equals 15 times 10 is 150 plus 12. And therefore, we're going to add it together. So our total cost, 150 plus 12 equals 162. So we're looking for our cost here, which is our output. And we found our output by substituting our input value, which is the number of days. So now what I would like you to do is the you try section. Please read the problem, identify your initial value, your rate of change, define it, write it, and then answer the question, how much would you pay for 5 races? And we will discuss it in class. Thank you.